The globe is getting smaller. I'm going to delve deeper than the microscopic scale and explore the possibilities of working at a level a billion times smaller than the average scale we do today. This is called nanotechnology. There is a vast and largely unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. It's challenging to imagine how little an nanometer is, but let's try to picture it for a second. Nanotechnology refers to any technology on a nanoscale that has applications in the actual world. Nanotechnology is the science of making small, and by small, I mean extremely small things. The width of a pen tip is approximately 1 million nanometers, therefore it is not even close. I ran out of comparisons when a single sheet of paper is around 75,000 nanometers thick, and human hair is about 50,000 nanometers thick. So let's try something else. A chicken would be the size of the Earth if a nanometer were the size of a football, a coronavirus would be the size of an adult male, a donut would be the size of New Zealand, and so on. To put things into perspective, if every person on Earth were the size of a nanometer, they would all fit into a single Hot Wheels car. The nanoscale allows us to work with new domains and physics that don't really apply at any other scale. Nano is super tiny. We're talking subatomic, so that's how big or rather small a nanometer is. But why should we care about such tiny objects? Because they ultimately teach us about the universe in which we live. Since everything on Earth is made up of atoms, nanoscience and nanotechnology can be utilized to change the environment. Think for a moment about how a car works. It's not just about having all the right parts, they also need to be in the right place for the car to function properly. Well, in pretty much the same way that how the different atoms in something are arranged determines what pretty much anything around you does with nanotechnology, it's possible to manipulate things. When matter is controlled and arranged at the nanoscale, atoms and subatomic particles naturally exhibit odd and occasionally surprising behavior. When working at the nanoscale, we know that the properties of materials are size-dependent because of these alleged quantum phenomena, which govern the behavior and properties of particles. This means that scientists have the ability to modify and fine-tune the properties of materials, and they have actually been able to do this for a while now. For example, it is possible to change the melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity of a material. But where can we actually see the results of this kind of work? Well, everywhere, as there are many commercial products that you and I already use. We're reducing the size of computer chips, which is helping to increase memory capacity, making our smartphones even smarter with features like nanogenerators to charge our phones while we walk, and enabling the delivery and release of drugs to an exact location within the body with precise timing, making treatments more effective than ever before. Trucks, airplanes, boats, and spacecraft can be made out of increasingly lightweight materials. There are many potential applications, and those are only a handful. Let's examine a few of these in greater depth. Nanotechnology has played a crucial role in the advancement of electronics and computing, resulting in quicker, smaller, smarter, and more portable systems and products. Just 40 years ago, a computer that was tenfold slower was the size of a room. Today, it is entirely common to carry a computer in one hand. This has been made possible by the shrinking of the microprocessor industry, such as transistors. In the shortest possible time, the switches that enable all modern computing have shrunk dramatically from a size of about 250 nanometers in 2000 to just 1 nanometer in 2016. This revolution and shrinking of transistors may eventually make it possible to store the memory for an entire computer on a single, tiny chip. Nanoscale magnetic tunnel junctions have also enabled quicker systems, and because they can efficiently save data during a system shutdown utilizing magnetic RAM or random access memory, it is anticipated that soon computers will be able to boot practically rapidly. Semiconductor nanomembranes have been used to create flexible, bendable, foldable, and stretchable electronics. Because these monocrystalline structures are so thin and bendy, less than a few hundred nanometers in normal terms, they are particularly useful for wearable technology like smartwatches and smartphones. Nanotechnology can help us start to solve some of the world's greater and more urgent challenges, and it is undoubtedly the solution to a digital world that is focused on being smaller and more effective. Applications for identifying and removing environmental pollutants are numerous. It is anticipated that nanotechnology will significantly contribute to environmental and climate protection by conserving raw materials, energy, and water, reducing greenhouse gases, and enhancing the durability of materials so they last longer and generate less waste. Other potential contributions include the development of insulation materials that make paper towels more effective, enabling them to absorb 20 times their own weight. Nanotechnology has the ability to significantly improve both human and environmental conservation. It is becoming more and more urgent to ensure access to fresh, clean drinking water, which is related to population growth, pollution reduction in cities, and the widespread consequences of climate change-related events. Nanotechnology has the potential and ability to filter and purify contaminants as well as detect them. For example, arsenic can be removed by ultra-small dust particles by using their magnetic interactions. The development of nanoparticles that can purify water pollutants and are less expensive than the process of pumping it out of the ground for treatment also holds great promise. In short, getting clean water is a huge problem, and nanotechnology can help solve it. This is incredible given that it is naturally present at high levels in the groundwater in a number of countries. There must be drawbacks to the environment's seemingly limitless potential for use of nanotechnology. After all, quantifying and confirming a product's effects on the environment, both positive and negative, requires an examination of the product's entire life cycle, from the production of the raw material to disposal at the end of its life cycle. There is a genuine worry that the use of nanotechnology will further increase energy and environmental costs. Although the concept of subatomic disease-fighting machines has long been a staple of science fiction, we have only recently made significant progress toward realizing it. Although it may seem like a near-perfect solution to a number of contemporary medical issues, let's first consider how and where science fiction and reality intersect, as well as any potential obstacles. Medical equipment already substantially incorporates nanotechnology. Techniques and knowledge that are already commonly used. Nanomedicine is the use of nanotechnology in medicine for the purpose of preventing disease. Diagnostics and therapeutics researchers are working on ways to use nanoparticles to encapsulate or otherwise help deliver medication directly to cancer cells while reducing the risk of harm to healthy tissue. This could ultimately change how cancer is currently treated and significantly lessen the toxic effects of chemotherapy. Increased success rates for numerous various therapies are also being made possible by the enhanced imaging and diagnostic capabilities made possible by nanotechnology. Due to their ability to behave like naturally occurring atoms or molecules due to those quantum phenomena I mentioned earlier, quantum dots, which are tiny semiconductor particles just a few nanometers in size, are sometimes referred to as artificial atoms. As a result, they have many applications and are widely used in various sectors, but producing quantum dots is an extremely expensive process. Tea leaves. The process is inexpensive, the byproducts are non-toxic, and the results are truly amazing with tons of potential. Research shows that the quantum dots made from tea leaves can penetrate the skin and slow the growth of cancer cells by about 80%. This is not a cure, but a significant step forward in progress without any negative environmental effects. Nanomedicine can also change how we treat minor illnesses. In order to one day create human organs for transplant, researchers are currently investigating ways to generate complex tissues. The delivery of vaccines without the use of needles, which is still a work in progress though an amazing feat once accomplished, can also be improved by nanotechnology. However, the emerging era in nanomedicine is really the era of the nanobot. Nanorobots are developing tiny packages that can complete tasks in an automated way. They hold the ability to sense, respond, detect friend or foe within the body, and deliver payloads and cars. Nanobots also hold the potential to totally replace pacemakers by treating the heart cells directly. They can be fitted with wireless transmitters so that doctors can alter the treatment approach to particularly respond to the state of the medical condition. The development of artificial antibodies, white and red blood cells, and antiviral nanobots, all of which are extremely robust and could theoretically function for years without suffering any harm, offers various prospects in the field of medicine. Nanorobotics holds considerable promise for advancing medical progress, but the phrase "so close yet so far" comes to mind because there are still human limitations to its use. Nanobots, in fact, hold the potential to address many health problems besides cancer, such as unblocking blood vessels in difficult-to-reach areas, taking biopsies, or measuring the level of certain chemicals in otherwise inaccessible areas of the body. Before the potential of nanobots and medicine can completely be fulfilled, scientists have several obstacles to overcome. While nanobots hold the key to an infinitely less toxic solution to treating cancer, the challenges in getting the solution to the stage of becoming a reality are great. Getting the boss to travel safely where we want them to in the body, and actually having them stay there long enough to carry out a procedure, is extremely difficult. Scientists have also yet to figure out how to keep the nanobots from being destroyed and expelled from the body like any other toxic or foreign bodies. If you enjoyed our video, don't forget to like, share, and subscribe to our channel for more tech-related videos.